Check, check, check. Is it better now? Something happened with all my audio and stuff. And I don't know what. But it looks like we got it now. And my system audio and everything? Okay. All right, sorry about that, guys. I'll just start over. Hey, guys, how's it going? Welcome to another episode of Ferris Makes Demos. This is episode 23, where I'm doing some Evoke live show prep. Although, you'll notice we're about 15 minutes early. So I thought we should watch some demos from Assembly because I'm just sitting here at this point. And I'm too scatterbrained to just start diving in right before the stream. So why don't we just watch a couple demos. Now, for those of you guys that don't know, Assembly is a big demo party in Finland. Happens in August every year. There's also a winter edition, apparently. But I don't think they have demo competitions. Historically, Assembly has been a really sort of prestigious event in terms of demo scene competitions. A bit less so in previous years, but there's still some really, really great releases happening there. And in particular, there's a couple of these that I really want to watch. One of them has already shot straight up to halfway through the top of the month, and I expect it to overtake us up here pretty quick here. But until it does, I get to enjoy this. But I think we should watch this because this is a demo called, I think it's Sokia. I don't actually know how to say that, but it's totally awesome. By Fairlight. I think we should watch that first. In real time, by the way. Because I already have it downloaded. It's literally distributed as a like 120 megabyte executable. No README or anything. Don't want full screen, don't want looped. Here's some resolution that's nice. Yeah, let's give that a shot. Oh no. Oh no, I can't move the window. Hold on. Hold on. Here, I know what I can do for this. I can just move my screen. How's that? That should work. A little more. There we go. Flat out, I think this demo is fantastic. I'm just going to say that up front. Have fun, encoder. Love this style.
Understand?
Oh, what a cool demo. And it loops. I think that is so rad, by the way. Here, let me move this window away from you guys. Oh, but yeah, I think that demo is so rad. I believe it placed second at Assembly. The next one I wanted to watch was the Epoch one. I believe it was called... Hold up, I'm actually going to move my screen back. Nice. Where'd it go? Extra. It's called Extra. I think this window I can move. There we go. Very nice demos. Yeah, so I didn't do a proper intro really yet because we're a bit early, so I thought we would just watch a couple of these demos. But I guess we're about getting ready to start proper in terms of time, which I think is fine. Change some settings here while I'm at it. But yeah, I'll do kind of a more proper intro now. So hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. Particularly this week will be about some prep work that I'm doing for a live show that my demo group Logicoma is performing at a demo party called Evoke, which is in about 2 weeks. So that's the name of the show, which you can't see currently, and now you can. There you go. Oh no, wait, that's just Ferris. Okay, never mind. I guess that was visible already. But yeah, so that's why I call this Evoke Live Show Prep, because we're going to be doing a bit of that prep work. Particularly, going to be editing the tool a bit. I've made a couple adjustments here in the tool. So this, you guys have probably seen before in a previous episode, just something I threw together on the stream at one point. And the idea behind the live show that we're doing is we've got basically, we're doing like a music thing. It was originally a musical performance, sort of a live DJ thing. But in addition to that, of course, since there's 3 of us that's going to be there, what are all 3 of us going to do on stage? Well, I can pull up the demo tool and make a full screen mode. So that's the first thing I did, is make this full screen toggle. Now, of course, I think you guys only get the top quarter of the screen when I turn that on. But it appears to work at least. So that's pretty cool. So basically we'll have like DJ stuff set up, and then we'll also have VJ stuff set up on the same stage. So from one laptop, we're going to be producing audio and some MIDI signals, and from the other laptop, I'm going to be taking in those MIDI signals and producing live visuals in real time, hopefully in a sort of VJ-ish layered kind of way. So first of all, what I need to do is I need to sort of prep our tool to be able to do this stuff. So there's a couple things that I've gone through and added. The first thing is that originally we only had the concept of time in terms of the sync tracker. So we have this little thing here where we can sort of set parameters, and as we move time around there, we can, change parameters over time. And this is really useful, of course, if we're making a demo, because then we can, sync the whole thing on a timeline. However, for live performance, we want just a time that's sort of monotonically increasing, and we don't want to like play any music or anything from this machine. So I added something called test time, which just sits there and just always increases, and then when it gets to a minute, it wraps around. So it always goes from 0 to 60 seconds. And that's for floating point precision, because this gets converted to a floating point value and then sent up to the shaders. So keeping it within that range is nice. It also keeps things a little more predictable. So in this case, this thing that I just added here just sets time to be the test time for the actual context of the demo. So the exact same code that I wrote before is actually just always running now without me having to actually do anything in the sync tracker, which is kind of cool. So that's what that is. I'm going to basically be taking a lot of effects that we've done previously and sort of making them work in this kind of format and making them work with each other and sort of the same 1 or 2 post pipelines, and be rendering that to layers. I'll probably also do it at a lower resolution. I'll probably do everything in 720p and then mix it all together in 1080 or something, just in order to save some processing power, because we will have to do this on my laptop. So that's the first thing I did. Then the full screen toggle. And then the other stuff that I'm doing, which is what I want to focus on the stream today, is actually adding MIDI to the mix. So I have a couple MIDI controllers here. I have an OP1 from Teenage Engineering, and I have an Axiom 25 from M Audio that I got like 10 years ago from my brother. From my brother. And what I basically want to do is I need MIDI from Hoffman's laptop, which is going to be playing the audio, but of course I don't have that to set up with, so that's why I have 2 MIDI controllers here. So I need to simulate getting MIDI from one of them and also getting MIDI from the other. And what I think I'm going to do is in our grid language here, we have, like, for example, to get parameters from the sync tracker, we have certain kinds of, we have a certain syntax to get variables from there. Let's see if I can, here's one. So this is a scene selector, so you have this sort of thing that looks like a function, but really it's parsed into a specific AST node. Or expression node in the AST. And this will get a track from the tracker with the name scene in quotes like this. So in this case, it's 0. If I change this to 1, for example, nothing actually happens. It just looks like it freezes, and that's because nothing's actually drawing now. every frame, but then this is the context is left over. If I resize the viewport, for example, it gets cleared because that will actually reallocate the frame buffers. And if I set it back to 0, we have this initial scene here. So that's one of the things that we want to be able to do from MIDI. Another thing is just tweaking effects, doing things like moving around. Like currently I do that with the mouse, but that's going to be a little disturbing to have the mouse pointer on the screen during the live show, so I'm going to rig that up to MIDI as well. So we need to kind of port a lot of the effects over and sort of rig those to MIDI, but before we do that, we actually need MIDI to work in the tool. So instead of doing like sync like this, I want to do something like MIDI CC, and then we give the device name, so like OP-1, and then we'll do signal CC1 or something. And then this will get translated into some stuff underneath that it, on export, this actually won't do anything. We'll just basically no-op that. And then otherwise it'll, yeah, do what we need to do. So that's what I'm thinking, and that's what I think we'll be working on today on the stream. Oh, I'm not used to having my chat over here. I rearranged a bunch of stuff in my apartment, so I'm kind of getting used to this setup, and maybe I'll move this window back. But yeah, let me catch up on chat for a sec here. Skeleton, I didn't notice that I had even linked that. I don't remember doing that. Where is that link? But yeah, for you guys who got here late, I actually started early, so we just watched some demos from Assembly that I thought were pretty cool. My two favorites from the party this weekend. I'll do my names in the chat shout out thing. Metal Voids, Move AX13H. That was my what my 256 colors comment was about, by the way. Skeleton, Kanuki, Soul Threads. Your Local Facts, Garrett Kelly. Rep Nop. Local Hoster, how's it going, guys? Under website. Where am I linking that? Hey, John Hunter. Hey, Zakor. I totally don't know where I'm linking that. I mean, if you go to evoke.eu, if you guys are curious about the party, that's all you need to do, but apparently I'm linking this somewhere as well. I'm going to mute my system audio and give myself a little bit of music here, by the way, because I need it. Scroll to Ferris and there's a website link there. What? First of all, I'm not seeing what you guys are seeing. That might help. Is that just like the last link I shared or something? Because like I don't at all remember setting that to any of my profile or anything. Also, search bar on the top. What? What are you talking about? Am I just missing something super obvious? I just legit don't know where that link is. Where I've shared that. I don't know. Well, I give up. Don't know how that link got there or whatever. Anyway. Adjust my volume here. So a couple things. Basically, to get MIDI in here, our demo tool's in Rust, as it always has been. Ah, yeah, the logicoma.io link doesn't point to anything. That makes more sense. Although... Oh, you know what I bet it is? I bet my security certs expired. That's probably what that is, actually. Hey, the tourist. I'm going to get myself a little Slack reminder to look into that. That's probably what it is. Yeah, that's probably security certs that expired. I need to set it up to auto-renew those from the servers. Hey, cool tourist. Good to see you. By the way, check out how precious I am today. I've got this shirt on where it's like black and I got one red sleeve. I'm literally my MSX right now, you guys. I had to do it. This is my life now. Okay, anyway. So I went looking for ways to get MIDI in Rust. I didn't want to just use the platform APIs. Ferris makes fashion. Yeah, let's be glad that's not a thing. Just makes me happy. Anyway, I found this library called Midier. I think you say that. And it looked minimal enough. It has some issues working on OS X. I don't really care about that right now. I mean, previously our demo tool has been built to work on OS X and Windows. I've been thinking about dropping the OS X support because I'm not using it right now, and none of the other guys are, of course. And I would really like to upgrade to OpenGL 4.2 and start getting 4.2 at least, and start getting compute shaders. So probably gonna, do that anyway. Yeah, Metal Voids, the event is a bit late, but it's because it's going to be after the competitions, but it should be pretty fun. Anyway, this MIDI library looked pretty nice. I went ahead and downloaded it and ran the tests, particularly this little test program. Let me adjust my font size. So prepared. I had way too much caffeine this weekend, and I'm feeling it, like in a bad way. Yeah, so here, see, I just ran the test, and it has a select which device we're getting input from, and also which device we're going to send output to. So, for example, if I set up to be my OP1, and then we put output on the wavetable synth, for example, then we can actually just get output as I press some keys here, turn some knobs. So there's a couple different kinds of input I want, basically. I would love these CC signals, so you can see that these are increasing as I'm turning this knob to the right, or they're decreasing as I'm turning this to the left. I would love to get those. These are different knobs here. I would love to get these just on like direct effect control, like have a feedback effect to control its amount and stuff through these knobs. That'd be pretty rad. Those would be nice. And then for keys, I would really like basically just to know when keys are pressed and released. Maybe not even like released, maybe just pressed. Because what this will basically be used for is that we're going to map some of these keys to drum pads. On my OP1, I have some drum pads. And I want to use the keys for switching parts, so I can like directly go to a certain one rather than a knob for that, which would kind of suck because you'd have to scroll through all the parts in between the ones you want. And the MIDI controller that we're going to use, which is Wobbles, has a lot more drum pads than the one that I have has. So we're going to do a few faders for different things, and then we're going to have the, like I said, the pads actually select effects. So all we should really need for that is just to know when a note, like if a note on on a given note happened within the last frame should be all we need to know. And same with the MIDI CC stuff. Like, we really just need to know what is the latest value at the given frame for a certain CC from a certain device. So we have multiple devices and we have to take care of that. And that's why I think the design of the little expression that I talked about earlier is going to work just fine for what we need here. Many devices doxed, yeah. That axiom, by the way, it's not that little. It's like maybe little in terms of key count, but this thing's actually pretty big. But I like it. Special edition yellow. Get that plugged back in. Also, let me move some of these windows around 1 second. Yeah, there we go. The window on my other monitor was not really working out for me there. But anyway, I think this library should give us what we need. Gonna be a little engineering here, but I think we'll just kind of shoehorn it. Normally, I would kind of like to do this stuff in isolation first, and then sort of bring it into the tool. But I think just how simple the usage of this is going to be, it's just going to make sense to just do it in the tool, which means it'll be a little while before we get stuff working, but I think that'll be fine. So the first thing I'm going to do is I need to actually add support for these kind of expressions in the tool itself. Now, usually this is one of the later things that I do, but I think it'll make sense to do it there first in this case, because usually what I do is will add operator types or something. But for an expression, I think it just makes most sense to just start there. We'll get to unit tests and stuff later. Probably won't even do that on the stream. But I'm in the AST file for the compiler that basically turns that grid of operators into a bytecode that gets executed. Basically, the process of, if you guys haven't seen my previous videos, is we have that grid of operators, and then that first gets translated into this AST, and then it's just kind of a normal compiler for that from there that goes into bytecode. So starting with the AST is a good place to start because it is. So the expressions are not that complicated. You only really have constant values, which are going to be float values. Expression that represents generating a random number, one that represents a reference to a variable with a string name, one that represents a reference to a sync track with a string name as well, and then you have unary operators and binary operators. The unary ones can do negation, sine, cosine, absolute value. The binaries are add, sub, mul, and div, and that's really it for this kind of expression language here. Oh, shoot, Dark Second. Good call. I totally did have that unmuted. Hold up. I'm going to fix that really quick in case I forget to do that again. My bad. That's a good catch. Thanks for that. I'm so pro, you guys. I can share what I'm listening to, by the way. Listening to Otographic Arts, which I really like. There you go. I can't play that out due to licensing. So hopefully my little VOD doesn't get muted. I might have to edit that out before I upload to YouTube, but we'll see. Anyway, really good stuff. So I'm just going to add another type of expression here. And so these are kind of the terminal values, and these are the ones that sort of branch out into additional expressions. So here I'll just do, I don't know, MIDI CC. Something like that. And so basically we want a string for the device name, and then I think we want a number for the CC ID, which in this case should just be a U8, I guess. That should be fine enough. I may actually make this a U32 though, to be honest. Or let's see, I don't remember how the parser is implemented, so we'll see. So after we have this in here, if I run this, the Rust compiler is actually going to tell me a bunch of places where I need to change the code. But before I do that, I want to hit up the parser that actually parses the grid into this. Now, most of the grid parsing and that sort of translating that into AST is going to be fairly, like we basically avoid that because we're not adding a new operator type. But instead there should be a parse identifier. There should be a parse expression. Yeah, parse expression function here. And we're going to head down there to where that function is here. And this literally just runs a nom-parser over the expression string here. So for this, I don't think this is going to be ridiculously complex at all. I think this is going to be really simple. In fact, here we have the sync one. And I'm basically going to make this, I'm going to start with this. Just fork what I did here. So we'll do MIDI CC. And then we'll do the left paren, right paren. And then we're not going to have track name here. First of all, this is going to be MIDI CC. And instead of track name, we want the device name. I think. May change this as we move on. We want the device name and then some optional space. We definitely want a comma here. And since these aren't actual like function calls, I don't really have anything in the syntax for just like doing a list of arguments. So that's why I just kind of do this by hand. And that's just totally fine in this case because we've already been delimited by this anyway. So I'm going to get the string name. And then actually I need this on either side of this. And then we'll do the actual CC ID. I need to actually MIDI CC terms just to make sure I'm using the right terminology here. I think that's going to be a bit nicer for me. I just pulled up the first thing on Google. MIDI port and or MIDI channel. Each port has 16 different channels that can be used to pass data. MIDI ports are often unique and unique hardware paths, typically indicated by a 5-pin connector. I don't think we need to differentiate on channel for now. We'll just do the port. And then I think that that's actually what we want. So I think rather than device name, I think this is actually going to be port name here. And then we don't want notes. We want the CC messages. This is a continue controller or control change here. Controller number is what we're after. And then a value, which we'll get to. The value isn't part of the expression here. So we'll do, controller number here. And then here we need to actually parse that. I think, how did I do like U32 and stuff down here? A lot of this is just kind of expanded in a pretty basic way, but it totally works. String literal. The concierge, so at least do number literal here. But I'm fairly certain I should have a couple down here for float numbers. Maybe I do that differently. Like I parse bool and stuff. Been a while since I've been in here. Like, what does it do for the U32 here in text? How does it do that? Parse number. Okay, so that actually just will do. That's kind of funny. But yeah, okay, so we'll do number literal, and then we'll cast it, and that should be fine. That should be fine. Here we'll do this, and I think at this point we can just do that. And we should be good to go. So that should be all we need for the parser. But then, of course, the rest of the compiler is going to need a lot of stuff. So I'm going to need to run a couple things here. Pull up my other command window. We're going to do nmake. And then the compiler is going to start telling us what sucks. So Apparently we got definition of sync ref, which is probably me doing this wrong. We need to do MIDI CC. Now, by the way, that just also reminded me that I need to put this in here as well to add it as one of the options of the expressions that's parsing. Now we get some good errors. So now this is in the rest of the compiler, and this is going to say like all the places where this particular pattern isn't covered. Now the first thing I'm going to do is basically ignore this in a lot of places in the compiler. A couple places we won't be able to do that, but some places we definitely will want to just ignore it, because a lot of them it's like searching for variable names and stuff, and that's not going to be relevant in this case. So we'll do that. We got to do some kind of complicated stuff here with this eventually, but it's going to be fine. So what's this? 326. So that's here, the variable scope. Yes, this is yeah, just searching for different kinds of variables and different types of expressions. And particularly here, this is kind of a terminal thing. So we're just going to not do anything for this. I think you can do it like that in Rust. I can't remember. I think you might have to do 2 fields here. Uh, 562. That's, yeah, again, ref counting variables, so we can ignore it here as well. I don't like to do just and the other ones. I like to actually list them out here when it's something like this, like matching on expression types, because it'd be so easy to miss where we might actually need to put one of these. So like I want to make the conscious decision to go through and decide for each one of these visitors if I want to include this or not. So that's why they're all listed out here, to kind of manipulate my future self into actually thinking about the decisions rather than just using catch-alls. Sync refs, so this is particularly looking for the sync refs, and we definitely don't want to look for one there. Probably going to copy this visitor as well when we do the MIDI one. So the way I have the compiler working is I have like it parses everything into an AST, and then it runs a bunch of visitors on it that just sit there and gather a bunch of data into this compiler context struct. And the visitors, their job is to sort of like there's an implementation that can take a visitor in the AST and just call functions on the visitor as it goes through the AST. This is a really common design pattern. But the idea is that you can kind of separate traversing the tree from the actual things that you're looking for as you're traversing the tree, if that makes sense. So the tree traversal is kind of external to the visitors, and the visitors just kind of updated when it, does a bunch of traversals of the tree. But the idea is we just need to suck a bunch of information out of and verify a bunch of information that's in the AST form before we can actually do certain things here. So I think down here, 1442 is the line number that I'm getting here, and I think that's in CodeGen, and that we'll just have to do this for now. Because I need to figure out a little bit more how this is going to work first. Yeah, this is emit, so this is going to actually take the compiled, we're appending to the list of opcodes, and we have the compiler context, and basically all the parsing has been done now, and all the verification, so now we're just emitting bytecode by appending onto this opcode list. And for this, we don't actually want to do anything yet, so we'll do this. Skeleton, why don't you jump directly to the line? Because I'm lazy and I haven't learned the key combo to do it. You guys are just going to have to deal with me scrolling. So yeah, so here I actually don't know how this is going to work yet. So we're going to need some more stuff here. Where would my parser go here? So we had, what did we call this? We had the, oops, let me see. We had the port name and the controller number. So we'll get those out, but then we won't do anything yet. So this should compile. And we should actually even be able to have this in the thing, but it will probably crash when I actually parse one of these properly. I'm guessing. In fact, what I might actually do, I'm going to stop the compilation here because I'm actually going to do this for now. Going to make it return 0, basically. Takes a minute to compile. This is kind of a big project at this point. Rust compile times are getting better, but I'm not taking advantage of any of that because we're on a nightly from like last October for other reasons that I'm totally not going to get into right now. Anyway, I'm going to test that I can like type in the MIDI CC thing and that the parser is going to work. But yeah, this won't actually produce any useful stuff yet. So the job of the compiler here is to kind of take that grid of operators and turn it into not only a bytecode sequence, but also a bunch of structures that represent metadata. So for example, things like sync tracks and just general variable references, as well as like render targets, all those things will have these metadata lists. So the opcodes will reference the items in those lists by index, and then it basically expects the runtime to have like set up all the assets and stuff that it actually needs when it actually needs them. But it's only going to refer to those by index. And so we need the sort of ordered list of metadata that will be used for like packing the intro data or just running it and like live reloading assets and stuff at runtime. So there's for the MIDI stuff, we're actually going to have to manage connections with the MIDI stuff as well. So there's going to be another metadata list for that. Anyway, if I go in here, I should be able to do test time plus MIDI CC, and if I do ASDF 4, for example, then this should work. If I start doing other things like strings, then I'm getting compilers here, which it compiles on like every keystroke, so it happens quite often. But if I put like 4.3, something like that, then it actually works, which is pretty cool. Of course, this is the same compiler over and over again, so we're not getting much in terms of anything interesting, but yeah. But this shows that the parser actually worked and that it is actually generating code, even though it's just generating constants for now, which is fine. So that works. Now what I want to do is I actually want to get the metadata that we'll need. So I want to basically capture, I think, just the... I don't think I need lists for the controller IDs because I can just put the U8 for just make sure I'm getting the controller numbers. I think since those are just U8s, I'm just going to dump those. Those are basically already indexed, so I can just put that out in the bytecode. But the port name, this needs to become an ordered list. So I think we need to basically just gather all the unique port names, and that should be all the visitor really needs to do in this case, and then produce the list. So what we need then, in this case, we have the sync names and the sync var indices, and there's a reason why we have variable indices. So the sync stuff, you get these different individual sync tracks that we refer to, and those end up getting translated into, like allocated into the variable table that the runtime program uses. So basically when, like actually at runtime, the code to read the sync variables is just reading another variable like it would any other variable. But the variable table will get sort of repopulated with the values for those sync tracks, and we'll do the same thing for the MIDI CC. So I'm just actually going to start copying stuff here. Yeah, and this will make sense as I do this. So we'll do MIDI CC port names here. You'll notice I'm using a B tree set rather than like a hash set in this case, and that's because I want to preserve the ordering. I want to have a deterministic order. In particular, like I could use a hash set here because we would still like be able to do index of when we actually do the references, and we would get like, yeah, we'd get a list that's consistent. But then because the regular implementation of hash set will use sip hash internally that has a random number generator, and it's like seeded randomly. So like between compiles, then we'll have different indices. It will still work, but the issue there is then it makes like testing harder, and it makes it harder for me to debug when stuff does go wrong. So B-tree set is just fine. And all this stuff is so way fast enough because we're really not doing that much work here. This compiler is really, really fast. So we'll do, the port names here, and then we can do the var indices as well. We'll do that. Just the same as we have there. So this is the compiler context again, which is the struct that the compiler is sort of stuffing a bunch of information into, and then right at the very end, it will take a bunch of the information out of this and then produce the stuff that it needs to do. So this is like the compile function. You can see here, it creates a new compiler context, runs all, or first it actually parses with the to get the AST, then it makes a new compiler context, runs all these visitors on that, and then we get sorted variable references. We start allocating the actual variables in the table. Here we allocate the sync variables. Another bunch of visitors to do like render targets and stuff, set up those tables. And then it does code gen, and then finally serializes everything. So it's like, it's, as far as compilers go, it's a really straightforward one, I think. But as with any compiler, there's a lot of code and there's a lot of stuff to do. But I don't know. I quite like how this turned out. Anyway, we're going to need default values for these. This one I'll use a hash map whenever the ordering is not important. So that's what that is. Or a hash set if that's the structure I need. But in particular, I want to copy the sync visitor as well. Just search for sync here. Sync ref visitor, that's what it's called. So for these visitors, I just have a struct. In this case, a lot of them are empty. And then I implement visit expression on these, which usually, actually, this is a helper. The important part is implementing the visitor trait for these. And then you'll get a node in the compiler context. And then you return a results because you can't actually fail here. A lot of these will check for errors. Now, a lot of these visitors end up doing a lot of the same stuff here, digging into the structure. I actually, now that I look at it, I'm not so sure that I was able to decouple things as nicely as I wanted to, but that's fine. Kind of code that's quite repetitive, but it just doesn't suck to work with, to be honest. So that's fine. So here we'll do MIDI CC visitor. And I really think most of this is going to be the same. Down here, we're going to be a little different when we get to the expressions, which is actually what this visit expression thing is doing here. So I think actually this probably stays the same. So here we'll just do different stuff here. This will end up going up here. So we'll do ref, or sorry, it was port name. And we'll get the controller number. Now I think, do I need the controller number here? I probably do. Or actually, I don't think I need this here because this is just the visitor that will do, like, I think we just need to gather up the port names. The controller numbers we can, since we're just going to dump into the bytecode as is, I don't think we actually need to keep track of those in the compiler context. We'll just emit those in the bytecode. So I think we actually don't need those. So here, I'm just going to basically do this. Context.MIDI CC port names, insert, we'll do name.clone, just to get, like, clone that, take ownership of it. And the nice thing here is that because this is a set, this will eliminate duplicates as well, and it will also order them alphabetically, which is quite nice for, again, testing and debugging. So that's all we need to do for that visitor. We need to actually make sure this runs the visitor, though, which we can do here. This needs to happen here because we're going to do some allocations and stuff with it. Actually, yeah, I do want it to happen here. And yeah, don't need to create it because this will just create it when you have an empty struct like that. So that should be that in terms of running the visitor. we really don't need to do a lot of complicated stuff for the MIDI ports. That should basically work. This will then, yeah, there's a description of how this is actually working, but it's basically doing, we're going to change this comment a little bit. Manual word wrapping here. Actually, here, if we wanted to do this with the variable mechanism, we would actually have to do this. I think actually we don't want to use the, we don't want to do the same thing as the sync refs. I think we're good there. So actually, we probably don't need to do this here, because we're not actually allocating variables. I'd kind of like to do these things as late as possible, to be honest. I think that's fine, I guess. Sync var indices. Yeah, so actually in here, we're not going to do the var indices. And I'm going to rename this to, whoops, not sync names here. Okay, I did do that, MIDI support names. But the var indices, I don't think I want to do here. In fact, I think actually we don't need any of this, because the indices will be the indices of the port names. And we'll just refer to those. I think that'll make sense. Okay. Nice and easy. Run this here. And actually, just capturing those, I think, is all this needs to do in terms of the compiler. So I think we're actually good with just running that. Yeah, I think we're fine. So then here, the sync names, we'll do the MIDI port names as well, like that. ACC port names. Yeah, this should just work. And then here, we'll put it here. And yeah, then the compiled program will have all this. This will break all of our tests because they won't have this struct defined, but that'll be really easy to fix. I think that's it for the whole thing, for the whole compiler here, which is quite nice. Oh yeah, and of course emitting. So for that, we need to have a new kind of opcode for this. So here we got to dig a little deeper. And for the opcodes themselves, I have them sort of stored in a couple places. I have this opcode enum, which is kind of like the compiler's version of the opcode. This is the structure that describes opcodes within the compiler. And then I have them enumerated as like actual numbers that the lower level stuff will actually use to execute it. So here, we're going to need a new kind of opcode. Down here, I have all these ones for the different expression types. And yeah, you'll notice the sync stuff isn't here because that gets converted into variable references. But for MIDI, we're going to want to put this here. So we'll do, yeah, MIDI CC. I think that's all we need here. But then, of course, or at least in terms of the name, but then we need the, I usually use U16s for these indices, and that tends to be fine, unless I do these for like all the text stuff and the uniform stuff. So this will be the index of the port, and then this will be the controller, or sorry, the, what do I call them? The controller number. Port name, controller number, or port index in this case, because that'll be converted into an ordered list. So that's that, and then to serialize this, we'll need to go down here. The serialization for this is going to be really simple. So we'll do like this. And I actually don't think I need these, but that's fine. Fit in with the other code here. So we'll do ret.push. This is going to be op. We'll just call it op MIDI CC. And then this won't exist yet, but we'll get there. We do push U16 with the port index, and then we're gonna, I think it's just ret.push when it's a U8 controller number. So this is literally pushing the bytes into the opcode byte stream. I think that's all we need there, and then we need to actually do this stuff in the lower level stuff, and we're gonna have to do some glue with some context stuff down there. I know this is kind of hard to follow because like this code doesn't open some of that other stuff, but I don't know. I need to do this, and I thought I would just do it on stream. So yeah, we need to go into, so this is the opus, which is the thing that does ops and the compiler and stuff, and then we need to go into the runtime. So we need to go into, I think there's an opcode thing here. Maybe that's just in the context, or actually it might even be here. Happy to hear it, Rebnop. Bytecode, here we go. This is the actual indices for all the different ops that I have here. I'm gonna insert it here. I like to sort of retain the same order that the operators use in the other parts of the compiler, which means I'm gonna offset these values by hand, and that's fine. It'll break the currently exported blob, but that doesn't matter because it just, yeah, we'll just re-export. Cool guys, thanks. So here we'll do op MIDI CC. And this will be 0x4a. And I'll just do this. Perfect. So that takes care of that. However, that's not all we need to do down here. So this is literally just like attaching the numbers to the names here. Now I think the last thing I do is go into the actual context, I think is where this is. Or no, it's mod in here in the JIT. So this is, now we're in the JIT compiler. So this is a thing that takes all of the different opcodes from the op stream that we just serialized, and then this is going to be at runtime and also in the tool actually produce an x86 stream from that. Super basic, really. And all we need to do is find this one, do op MIDI CC. Oops. And here, all I'm really going to do is just, I want to pull the other values out of the stream, and then just call a function, emit code to call a function with that. So all I'm going to do here, by the way, if you're more curious about this tool, I did one of my earlier streams goes over this in a bit more detail. But here we're just going to, I don't know, it's kind of cool to see changes to it as well, I think. So here I do some stuff here to deserialize the stuff from the actual stream. So we'll do the, we'll call this port index. And then the last thing we need is to just get the op. Now I can't remember how I do this for 8-bit values. Probably just this. Oh yeah, and there I even do source into to get those, but we don't need to actually convert this because it's just an index. So we'll just do this. This will be our controller number. And yeah, also here, we don't need to call this U16 port index because I usually prefix it with the type if it's like, this is that value, but in this specific type because we're about to change it later. But in this case, it's already in the right type, just getting it as a U16. So we'll get that. Ignore the unsafe code here. It's fine. And then the thing is that we need to push all this onto the stack. We'll probably, actually, now that I think about it, in order to simplify stack alignment, I am actually going to do this, where I prefix these, and there's a good reason for this. I'm basically going to convert these to U32s when I push them on the stack, because that's just going to be a little bit easier. Exactly, Tsoding. Yeah, at least this one's really easy because it's not dynamic in the sense that it'll just produce one blob and then that's it. And then whenever I make any code change, the whole thing just gets recompiled, which really simplifies things. What was I gonna do here? Yeah, I'm just gonna convert these, I think, when I emit the code here. I don't need to reinterpret anything. Or might as well do this, actually. Just to keep this kind of clean. I like to put the offset increments right next to the reading here. But yeah, I think this looks good. Then what I do here is we actually need to do the function call. Now, all I'm doing here is I'm just going to call back into Rust because that's going to be the easiest thing by far. So here we're just going to do something like this. Get MIDI CC impl, which is going to be the function that we're going to call back into. It's going to be std call function for reasons. And this is a function that shouldn't return anything, I think. Or actually, yeah, it totally should. Now that I think about it, this totally needs to. It's going to actually leave this in st0, which is what we want. So here we need this to take in the parameters, of course. That's going to be a U32 and a U32. Now, since we're going to push 4-byte value, and we need to. So we have a stack alignment that has to be 16-byte aligned. We're going to push 8 bytes with these two 4-byte values. So we need to do some stack adjustment here, which is what this sub ESP and add ESP is here. Oh yeah, and also we're actually going to need 4 more because of the context. So this is actually going to be this, because we're going to do 4 bytes here for the pointer to the context, 4 bytes for the first value, and 4 bytes for the second value. So this is all 12 bytes. And then we need to adjust the stack by 4 more bytes so that we're 16-byte aligned. So this should work. And then here we push everything in reverse order. So I think the way I've done this previously is instead of just pushing immediates, I've gone through EAX out of laziness. So that's fine. No need to worry about it. So that should do it, except for the implementation of this function. So now if we go down to ran impl, that's seed ran impl here. Yeah. I'll copy this comment as well. And yeah, here we need to do something on the context. So we're going to call back into the sort of engine through the context. We need to also get our port index, U32, and our controller number. Now, the easiest way to do this, honestly. Oh, I know why I had this on here. Just in case anything that this called would do anything with the FPU stack. That actually might be a bit nasty for this. Actually, it shouldn't be, though, because all the MIDI stuff should just do integer stuff. We're probably going to be okay. We'll see. If we run into crazy crash bugs, we'll know where to look. But honestly, I'm just going to defer this to something on the context. So like one of the things I did with the profiling is I defer through the context through this profiler object. And what that allowed me to do is ignore that in the exported code just by making a null profiler. And I'll do that same thing here, I think. So we'll do this, some MIDI object. And we'll do something like get CC value. And then we can give the port index and the controller number here. In fact, I'm even going to cast these back to U16 and this back to U8 here. Now that I think about it, there may be some crap here. We'll deal with that. And I also can use this because why not? Yeah. So this is all the glue logic we should need. And then after that, we should just be in regular Rust, except we can't use FPU, but that should be fine. Because as far as I know, the Rust compiler basically never generates FPU code. Unless you specifically tell it to, but I never do that. I'm a little bit worried that the library underneath the MIDI library might be doing some of that stuff, but hopefully it won't. We'll see. This will be fun. And I mean, it's probably fine if it does anyway, as long as it doesn't cause us to blow the FPU stack, which is details. Hand wave. Yeah, so I think this should be fine. And then we just need to make sure our context actually has some kind of MIDI object. So we'll do interface for that, and then we'll actually implement this function. So we'll go to the context. And up here, there should be, maybe I had that on profiler. Yeah, so I actually separated these out, which is nice. So we'll do, in the runtime, we'll add a MIDI file as well. Yeah, that's exactly it, RepNop. It just says, yeah, as whatever, just whatever you can make this fit as. And I do it a lot for like function parameters when it's like I have some kind of integer value and just it takes a U16 or U8. I don't really care. Just do your thing. That's sort of the idea there. But this is really just, we're just going to make a trait here. We'll just call it MIDI because I don't feel very creative today. And then I should just need the get CC value here. We need mute self. It's going to return F32. Mute self, and then we'll need the port index. And then the controller number. And then the context will take one of these objects. And then, yeah, so here's a profiler. We'll do the same thing here. Actually, we'll do it underneath here. Just to tie the lifetimes together, we do that stuff. And then I think we need here. The most convoluted way to write a pointer, but you know, lifetimes and shit. And really all we just need to do is stick it on that object. These kind of context objects can sometimes blow up, but this is a common pattern to just kind of refer to one sort of big object. In a lot of cases, like a lot of books will tell you this is an anti-pattern. And those books typically don't deal with systems programming, so context is everything. Well, I meant context in terms of programming design decisions, but it kind of also is what this context is. It's kind of everything, so that's kind of funny, actually. Anyway, so that should be all we need to do down here, and then the individual implementations of the context are what are going to be interesting here. If I do nmake here, we're going to get some errors higher up in the stack. Okay, a couple things. I missed importing the MIDI thing here. No worries. Okay, I may have just saved this in the wrong place because I tend to do that stuff. Or actually, here's what I did. I didn't do the in lib. I didn't include it here. Do it here. This needs to be public because things, the actual implementations of this are going to be in other packages. Yeah, exactly. Upstart context with a lifetime of A is everything. Stuff is deep, man. Yeah. By the way, great error, Rust compiler. So true. What it's telling me is that in my implementation here, this actually needs to return this value. And it knew that the last statement here in my function would have had, this expression would have had the right return type here. So that is a great error. Ferris makes philosophy. Another thing that should never exist. Okay, so here we have, this is in the compiler now. Name and resolve name. Okay, yeah, that's actually, that was in here because I called this port name. Yeah, Rust errors are really good until you do macros. Really good until you do macros. Also a big appeal for me with Rust. Also, we can go ahead and fix this now. Because it's really just going to be... So we'll do this. Var port index. Oops, not var. Let. I've been doing too much C# at work. Context. And these are going to be the MIDI CC port names. Actually, we need the indices here. I think I have that somewhere up here. Here we go. Do one of these. I don't need to write code. Writing code's for scrubs. Nice. There we go. Yeah, no sub button still. Gonna be a while indeed. I don't mind the annoyance. In fact, I quite appreciate the interest. So thanks, guys. Oh, whoops. I did not mean to run that. I meant to go to the other terminal and build. Okay, so at some point... I use after move. Oh, yep, I know what I did here. Because I just copied and pasted this thing here. Oops, 117. Or is that where that was? 177. Yeah, so sync names, we need the ACC port names. This is my tactic to have you guys give me more money later. If I make them hold out, they're going to be so frustrated later that when I finally open the subs, they're going to be so stoked that they give me all the money. Now, that would actually be a terrible plan. I would advise you guys not to do that on your own channels. If you ever have a channel, or maybe you do, I don't know. Yeah, so now we have... now we're getting an error when it's creating this context because we never specified an implementation of the MIDI object. So that is exactly what we wanted to see at this point. So that is in... That's a bit higher up the stack here in editor context. And it's actually right here because that was in this code earlier. Here it creates the context. So, yeah, here we do. Wonder why I put that on the model store. That seems like a weird place to have that. But I'm probably going to copy that pattern for now. This is why I think. It's because when we get the... Yeah, it's just easier to hook this up with the recompile. Yeah, I'll do that then. You can see also here with the profiler, we have tool profiler, which is the, yeah, profiler for the tool, so the actual implementation of that particular trait. And then we'll do the same thing here for the tool MIDI. We'll get to this. Yeah, I'll do the same thing here. A lot of just hooking stuff up when adding features like this, but it should all be pretty nice in the end. And it should only touch Rust, actually, which is kind of neat. Don't have to touch the C++ parts of the stack today, I think. So I think that's fine. Tool MIDI there, and then here we need to create one. Here, do the new. Oh, that's why. So I could get the one from the compiled model. Yeah, do some crap here with recompile. That's fine. So this is like basically where we take those ordered lists of the port names and send them into the actual MIDI object. And we do that there when we initially create this model store from a compiled model, and we do that as well on recompile. So let's do here. That's good enough for now. Because yeah, get to the implementation, but I want to do the plumbing first. I think that's basically everything though, except now here we need to actually pass the reference to this when we create the context. And that's just going to be the same as what we have up here. Indeed, skeleton. No, I totally see the value of having additional channels for which to accept donations, and I'm totally on board with that. I just have to do some looking up tax laws and some paperwork, and have to talk with my CPA about that. So I'll get on it eventually. I just have not done that yet. So now we actually haven't created this tool MIDI type here. Yeah. Don't know what's going to go on there yet. Yeah, that's fine for now. And then we need to get the MIDI from here. How did I link that in? Yeah, let's do it the same way here. That should be impl MIDI for tool MIDI. And there was that one function. And we had U16 port index and U8 controller number. That's going to return F32, and for now we're going to do 0.0 and do a to do. In fact, I'm actually going to make this like 1, just so we can see a definite difference and that this will work with the entire stack for now. In fact, let's even do a fun number. Yeah, that should actually be enough to do the plumbing. Unless I missed something, which... Oh, yeah, syntax, guys. Don't learn more than one programming language, because you'll make stupid mistakes like this all the time. That's terrible advice. Never take my advice. Yeah, we need to... Come on my live. Exactly. Alkama understands. Hey, Drewer2, by the way, I checked out your streams finally. Just hopped on there and looked at one of your VODs. It's good stuff. Drewer2's making a Vectruck simulator. Go check out his stream because it's awesome. Just to throw that out there. Nice, Repnop. This built. So now I should be able to run this. And let's say I did the time, because that's just right here. So it's nice and easy. So we can do plus MIDI CC. And we'll do some port name, and then the port number here. Now if I remove this, if I cut this and paste this, our time gets adjusted, which means this is totally working. Now it's not actually doing anything with MIDI, but we got all this stuff through the whole stack. Now I didn't implement it on export, which is going to be fine for now. In fact, I'm probably not going to do it specifically. I'm doing all this stuff on a branch that's like specifically for this show. And the reason is because like if we decide that this MIDI thing sucks, I don't want to pull it into master. So it's kind of a big experiment even to try and use this tool for anything live. So I'm not going to do the export or the tests for now, because it'll be easy to kind of retrofit later, I think. Hey, little XMTex. So yeah, I think that'll be good. Yeah, no worries, Dura2. It's a cool stream. Yeah. Admittedly, I don't watch other people stream as much as I would like to, but I am very happy to share other programming streams I think are cool. So yeah, I think this is great. I'm going to actually save this so that when I start that up, I can do this. Now, I need to do a couple things for the MIDI stuff. I'm also going to, like, one of the things I do in this tool a lot is I just dump a lot of, like, console stuff. Usually I use this for, like, errors. But, like, for export and stuff, I'll dump out some other things, like whether or not it actually worked, that kind of stuff. And I just use the regular console because making my own console just seems like a dumb idea for me when I'm the one using this tool, and I always start it from command line anyway. But what I think I'll do is for the MIDI stuff, I will probably like dump out the available MIDI ports whenever the tool starts up, because we should be able to enumerate those. So when it creates this object, I'll just have it print that out. And yeah, that way I'll be able to actually see which ones are available when I want to use them in the tool. That should be good. And I think that's where we'll end up starting here. So yeah, I'm just gonna look up the Midir things here. I'm saying Midir. I don't know how it's supposed to be pronounced. Midir. I don't know. Midir sounds nice to me. So we'll do the. We don't need this anywhere in the stack except in this particular project. So we only need the dependency here. So yeah, we'll do here because all these ones are like specific projects as part of this demo tool. So yeah. MIDI R equals 0.3 should be enough. Hey, Garrett Kelly. If you come up with something, I totally recommend doing it, Repnop, if you're thinking about doing it. Because either you find it fun or you don't. And I think programming streams are rad as shit, so. So I always rebuild this stuff like as soon as I just add a dependency just to make sure. Maybe not always, but I like to. I actually need to upgrade my internet connection. I'm like at my upload limit every stream. Cha. I think I actually increased my bitrate as well recently. I had it intentionally low for doing textual stuff, but because I've been doing more graphics and things like that, then I think I turned it up recently. Anyway, okay, so that built at least, and then we're going to actually use this thing. So here we're gonna do this good stuff. I might start saying MIDI R actually. Probably what that was meant to be. Anyway. Now, the actual implementation of this is going to be a little bit messy, I think. We're going to have to deal with, I think, like, a bunch of, like, how do I put this? I think the listeners for each port is probably going to end up on a different thread. So we'll use the, like, I really like the Rust, what is it called? Why am I forgetting the MPSC stuff, the signals? I really like that API because you can just fire off a ton of threads and just send with those little messages back and forth, and it just ends up being a fairly nice programming model for stuff like this. So I do it for like every file asset that this loads, like all the shaders. I use it for that. So each asset actually has its own like file watching thread, which is fine because it's idle 99% of the time. But then whenever we get a message, we just shove that onto a queue, and then there's a frame that just pulls all the messages off those queues as well. Or there's a loop in the frame code that does that. So it just, kind of turns out nice. Sometimes it can get a little bit messy, but it's a lot safer than a lot of threading code that I've had to write in other languages before. So it's pretty nice. Hey, Saphira. Oh, that's cool to her too. Appreciate that. Yeah, the channel API, exactly. I mean, it's really basic, but in the way that it's one of those things that just is rock solid, and it's the right primitives for a lot of the stuff I end up doing. That's what I really like about it. So I quite like that. Although I'm the kind of guy who writes in 5 languages a day, so I always forget the syntax, always forget the API. So I'll have to look it up in my other code. But I used to be really self-conscious about that. Now I'm just not. As long as you know how to use the tools and you know where to get the information, doesn't matter that you have to look it up, I think. I mean, some of the obvious stuff would be annoying to look up all the time, but you know. So particularly the dynamic asset manager does a lot of this stuff. And this actually is kind of too complicated code for a lot of this stuff, the way it like retries and stuff. But I think it's fine. But actually, for the MIDI stuff, we're just going to start with loading up this library and just listing out the input ports for now. We shouldn't actually have to do any MIDI output, which is nice. Just input. So in this case, looks like there's I'm just looking at the test example here that comes with MIDI R. Yeah, exactly, Drew, too. All the tabs. So in this case, we're just going to make a new MIDI input object, I guess. And then, so there's MIDI input object, and then you can enumerate the ports. Grab their names. Yeah, so I'm glad that we used the right names for like port name and stuff, because then we can just look at this and it just makes sense. But yeah. We may actually not need the channel stuff. We'll see. Anyway, I'm going to create this first. Input, and this was... I'm going to start with this. And a lot of the things in the tool in particular that I do, I actually have a lot of panics in the tool. which is good enough for what I'm doing here. Like there are certain parts of the tool that I make sure like very much shouldn't panic, like the compiler will have errors due to the user input. And that I really don't want to panic, but in a lot of cases, like if I can't open the MIDI thing, then I'm just gonna crash. It's gonna be fine. Although if I have like the wrong port name, then I'm gonna just print that as an error on the console. So I'm gonna sort of differentiate there. But for example, here, like MIDI input new is clearly giving a result here due to the use of try, and I'm just gonna unwrap that. I don't know what this ignore thing is. It might be like a filter for these things. Let's just do what this says first. And then just gonna go through the ports. In fact, I'm just gonna do this. And just copy it. Because why not? Great. I've actually been hearing a lot of good things about Edge, generally. This takes a parameter for MIDI input new. We have to name it. Don't know why we're doing that, but that should be fine. Nah, I want that lowercase. Control C. Die, compiler, die. It's important. All right, now we have linker fun. And here's why. I'm guessing we're not linking against one of these, actually, which is probably WinMM. Yeah, MIDI and Gitnum devs. Yeah, probably WinMM. So the reason why we're not getting this is because I'm building this as a static library that then is linked into a C++ project. So we have to manage some of these dependencies by hand. But it's nice because the compiler spits out which ones we need. I'm guessing WinMM is the one we're missing here, judging by what I know of the Windows API and the symbols that are missing here. So in my, where is it? My Qt project, which is editor.pro here. Yeah, WinMM is missing. We actually want to preserve the order here, which is kind of a dumb thing, especially because there's a bunch of these that are repeated, but we'll do it here. Do that, and then I need to do qmake again. So I got all these terminals. Qmake is fine. We do nmake here, and then now linked properly. So now I can run the tool. And now we have the available MIDI ports here, which is perfect. So what I want to do is we'll do the OP1 first because it's closer to my hand. And here, when we take the MIDI thing, this is where I'm going to have the MIDI port here. And then we're going to take Control 5. That's actually not what I want to do. In fact, I want to run the example for MIDI-R again, because I want to see where these are mapped to. So I want to do, so this looks like the control is 1 if I'm just reading this right. So we'll set that as 1 for now. And again, it won't do anything yet, but should in the future. So this is how I kind of imagine this feature to look like, which is nice. Now this is getting exciting. Yeah, I totally agree that Rust is definitely a mix of like C-style languages and the ML family. And that's why I like it a lot. Yeah, for me, Rust was a pretty natural choice because I had like done C++ and C# and C professionally, and like because I was involved at the demo scene since I was so young, like I just had that was where all my experience was in that kind of family of languages. And then I discovered FP a few years ago, and because I was doing so much .NET stuff, I dug really deep into F#. So then by the time I saw Rust, it was like, oh, here's things from the things I know, and it's all the things I like in one place, and I can do native code. So just made sense to me. But yeah. So what I want to do here, first, I actually think I want to take a break and get some water. And when we come back, I'll do some more stuff to make this work. So I'll be right back. And I'm back. I just noticed something funny about Rep Nop's username, because he probably chose that name because it was kind of humorous that would be a funny thing to do. But if you guys have seen my recent C64 stuff, there's several places where I use no-ops to wait until a certain cycle. So it's kind of funny that it is actually useful in some contexts. Just so you know. That kind of thing's really common in old school stuff. Anyway. So I think like what I'm kind of concerned about is I don't know what thread those messages are going to be coming on. It seems like just looking at the example here, where'd that go? Where'd it go? There we go. Like, these messages are basically going to come in asynchronously, as far as I'm concerned. So this is where we're going to want to use a channel for this. So every connection we open, we're going to want to do that. So what we want to do here is, what I'm thinking is that we'll have we'll have a list of sort of things that we're connected to based on the port names. So we'll get from the compiled program, we'll get a list of port names, an ordered list. And what we'll want to do is, if we ever get like a recompile or the first time, for example, we need to just like take all the names in that list that we don't have in our MIDI objects list. And we need to actually try and open all those ports. If we can't open them for a given frame, then okay, well, we can't do that, or for a given recompile. So we'll just kind of produce an error. But otherwise, we'll do that. If it's already open, we can skip it. And then if we end up with having an open port that's no longer in the compiled program list, that means the user has removed an expression that referred to that port. So we can remove that as well and disconnect. Should be really similar to how I'm doing assets as well. But yeah, so we'll need like a frame callback here, which is where we'll basically pull all the messages off the channel and see if we need to update stuff. Or for the actual MIDI messages, because we're going to need... Yeah. A lot of details here, but it'll make sense as I kind of sit here and flesh it out, I think. Also, I want to look at the... Yeah, so the profiler here gets an update, which is called every frame, I'm guessing, and then update event names, which is going to be like the port name. So we're actually going to copy this, basically. Of course, this is going to be update port names. And we just get a compiled program, which is fine. So this, I will do to do. How did I do this? Oh, yeah, that makes sense. Yeah, just rebuild those every time. Okay. Yeah, so we're going to do the... This is going to be fine. This seems silly, but may have made sense depending on the collection that I had from there. Because really, I think we're just going to want to clone this for now. That sounds really cool, Upnop. Just reading the chat here. Getting distracted by fun stuff. Yeah. So just going to hook this up here from the editor context. Or is this where I do this? Ah, here we go. So here we need to update every frame. We want to update the MIDI stuff to make sure we have the latest data. And then on recompiles, which was in model store, I think. Here, we want to do this. So whenever on our initial compile, and then whenever we recompile, we need to tell the MIDI object that the port names need to be updated, and then it will disconnect from ports that it doesn't care about anymore, and then reconnect for ports it may have to do. So that should make sense. And then, where'd it go? Where'd my tool MIDI go? So I think all we need to do, make a map of these. From the name to something that I'm not sure yet. To a connection, I think, is what we want to do. Something like that. Whoops. I'm typifying. This is kind of funny. That's actually what we wanted. We'll do, yeah. Man, I'm good at typing today. Okay, so I think, yeah, and then here we do this. Nice. Best part about mode 13H, linear frame buffer. Straight up. Looking forward to your upcoming intros, so design. I think the next demo I'll end up doing is either going to be a PC64K or something on MSX. Definitely have to do another C64 4K intro at some point because I've already had ideas for that. Got to do something on my Amiga. Oh, by the way, check this out. Hardware. I just got a Gotek, which is a floppy drive emulator. Let's see if I can show this. So rather than having an actual floppy drive, I have this floppy drive emulator that uses USB instead. Now, I had to remove the original drive. And the thing is that because of the way this is shaped, it's not going to fit in there unless you cut up the case. And I really didn't want to do that. I wanted to be this kind of as like least intrusive as possible. So I just removed the original drive, added a couple extension cables, and I just mounted this to the top of the case here with some sticky tape. But yeah, this actually works really well. So now I actually have a way to get code on the Amiga, which I'm pretty happy about. But I haven't done anything with it yet. So, but yeah, wanted to share because old hardware's fun. Surrounded by machines here. It's fun. Somewhat considering getting a similar solution for the MSX, but as far as I understand, you need to make like a selector program, and I at least don't think there are any made for that platform already. There might be though, not sure. And I also, for some reason, I don't mind doing that to the Amiga, but I kind of don't want to do it to the MSX. I don't know why. Plus, I like the Pentium disk setup that I have set up now, so it's kind of funny. Ultra Satan HDD emulator. I hadn't heard of that one. I've played like none of the retro games for these platforms. I'm not that into them, to be honest. Like, I'm really into like Super Nintendo games and N64 games, like the stuff I grew up with. But for a lot of these old computers, I'm mostly just interested in making demos on them. Was that to get it to work with the 600 sort of design? Or was that for another reason? Just curious why you had to update the firmware. Actually, we don't need to clone this if we're not taking the data. We just need to grab it. Let's do this. Truck connection. For the connection, we want probably the object that we get from here, and then we probably want to have the join handle for the thread, and also we're gonna want a transmitter. So what I like to do with these is, we probably this object probably encompasses all of that, because when we close it, this will just shut down. So we're actually probably okay there. Okay, so let's look at that. I need to find the proper documentation for this crate, which maybe it doesn't have. Because I'm not seeing any links here, at least. Let's just look at the source. Particularly, we're looking for a function called connect. I'll just search that. I'm not getting that. So I guess we'll do the MIDI in is this MIDI input. Okay, is that just not on in this file? That's probably fine. Okay, it's here. MIDI input connection of T, where T is send. Some kind of data. Oh yeah, this actually specifies unit here. Okay. That's fine. Let's try that. Actually, maybe that's what we end up using. Well, I could just actually move the transmitter into this thread here. Or, no, I can't. I actually probably need to pull that off here, which is probably actually what this parameter is too. Okay, starting to kind of see how this works. But we'll just start with a connection. Which, screw this, we'll probably just try to do this. I think that's all we need for that. No, because we need the F as well. Which in this case, I always forget the function pointer things in Rust. Okay, it's actually really simple. And I did actually have this right. So we'll do these things. And it's going to be unit. This also needs send and static, which might be annoying to write here. Oh, I already did that all comma. I did that this morning. I just full screen the whole window, which is fine. Even easier. And then, yeah, I think we're okay here. Nasty type, but I've had worse. Yeah, I think. Oops, that was the wrong one. I just want to run this just to make sure I got the syntax there right. This terminal. I expected one type argument for that. Oh yeah, I guess the connection itself just needs the data, doesn't it? Dirt. That helps. Yeah, I'll just do that. Okay, cool. So in this case, it actually gets really easy because then if we have this map of connections, then we can just loop through and remove any of these, like any connection that's in the list whose key is not in this list. Then we just remove it from the hash map and it should close the connection properly. And then we'll just go through and all the ones in this list that aren't in this list, we'll just add them by opening new connections, trying to find them by name. So it should actually be pretty basic here, which is really good. And I'll just have it print out the messages for now. Eventually, we're going to send them over a channel, which we will then pick up here. Going to dequeue all those. And then we're going to store those into whatever internal structures that may be necessary for the connections. In fact, might even split this up so that instead of collecting them here, the connections we turn into a different struct, and on all the connections we collect all the messages for those, because that might make the implementation of this a bit simpler. We'll see. But yeah, this port index here. Yeah, come to think of it, we actually need to order this because we need the indices here, unless we have an additional map that will be the name map or the name to or index to name map, that is. Which that can just be an ordered list of names. I don't typically mind having those kind of parallel structures. Sometimes it's nice, like in this case. So I think I'll do that actually. Port names is a B-tree map. Let's get reset my music. Give me a B-tree map, which we'll need to import here as well. Or actually, we actually just need the vector, because then we can just take the index of them. So we can just do vec of string here. This will be our list of names, and then, yeah, so then we'll just do this sort of indirect lookup where we look up the index here, and then, yeah, use the index to look up the string name, and then use that for this. That should be fine. Alternatively, we could also order this list, but I think this will be a little bit simpler. Maybe I'm wrong, but we'll see. A lot of things in my head right now, so if I make a dumb decision, it'll probably become clear later. So this will be vec new. In fact, we can do this even. And just replace the old one, which is fine. Because the indexing only matters when we look up values, and it's going to index through this list anyway. So that's actually fine. Yeah, and then we'll do this logic. So I think I'll do the removals first. Or it really doesn't matter. But yeah. We're going to add new connections, remove unused old connections. And that's actually the whole algorithm, because then everything else is untouched. So if you do for name in self.portnames.iter, then we'll get a reference to the name. And then we can look up the MIDI in thing here. By the way, we want to store this MIDI in on our struct as well. So that we actually have that down here. So I think we can just loop through like this. Actually, we'll do that when we add the connection, because first we just need to see if the connections contains this key. So if it doesn't contain the key, that is. I think that's, what is that? A rest hash map. Actually, we should use the entry API for this, which is a little bit better. Then we can do or actually, if we're just inserting it and then not using it, I actually prefer not to do that. The removal one could do that, perhaps. Or I think this is actually simpler than I'm thinking. Just got a lot going on in my head right now. So all we need to do is check availability and add it if it's not available. So it's either contains or contains key. It's contains key. And that's already referenced, so that already works. So if it doesn't contain this key and this name, then we're going to actually open up the new connection. And to do that, I need to find that example again. I'm going to pull this over to my other screen just to make this easier for me. The reason I'm not using a hash set for, or well, the reason I'm not using a hash set for the port names is because I want to maintain the ordering. That's why I'm using a vector for that. They're already guaranteed unique and in a certain order from the compiler, so that's why I'm using that. But yeah. The import is... Okay, the import's actually just a number, so you connect by number. So you take the self.MIDI in, or actually we need to also not actually connect if the name doesn't exist. So we'll do that first, where we actually need to loop over the names like we do here. A lot of nesting here, but this is fine. And so here's the port name, which we can again unwrap here, and if and we'll do this. This will make this a little nicer to write. I think we can do, or we probably can't do return here. Let's do it this way then. Let port index is none. And then we'll do this. We can do port index is some body wants, okay, no. I think that's that. And then here, if we have a port name that we didn't have a connection for, I think I just dump the I think I just print that out here. At least for now. Don't know why I'm not doing proper formatting here. Again, we don't want to panic in that case. So yes, that makes sense. Yeah, I also agree, Drew. Boot would be nice to have that. This is good enough for this scenario, though. Yeah, so now we go the other way. We need to do for I think we can just do something like this. I always forget how many parens and stuff I need here when I do it this way. But just need to order or go through here. I'll actually just do this. KVP in. KVP is key value pair. That's where I get that from. And we can do something like let mute remove keys is new vec. Actually, can the entry API remove stuff? That might be nice. See you later, Metal Voids. Now let's do this. And then I think we can use, I don't remember if that has a contains function, but the iterator should have that at least. Oh yeah, we get it through it being a slice, so that actually is fine. So we'll use that. Yeah, so if the key is not in the port name, so that means we have an old connection, then all we need to do is remove it. So we'll just do remove keys dot push kvp.key.clone. And then in the end, we just go through all the remove keys and just remove them from the list. So take ownership here. Why not? Although I actually think a little bit nicer if we don't, because then we already have a reference, and then we can just do self.connections. Is it remove? Yeah, it is. And then we give it a reference to the key. And that should basically be it, actually. Except here. Match on the port index. Or actually, when it's just some or none, sometimes I like to do if let some. Let's do this. No, it was because I missed it. Yeah, there you go, comma. Voila, exactly. I don't mind rebinding this name like this. It's fine. And then here we actually want to open this and start getting messages. And I'm just going to print the messages again, just to start out with. Piece by piece, easier for me. So now here I am actually gonna probably unwrap the result of this when it actually tries and makes the connection, because at that point, like, we know it's a valid port, we should be able to connect to it, and if we don't, that's a problem that, like, the user can't solve by fixing data. So that's kind of, I think, where I want to draw that line. Yeah. So then this is gonna be the connection self.midi in.connect. We do the port index as whatever type. Although that actually should be fine as this. Or don't know what those names are for, but whatever. Don't need that user data right now. Do that. I'm just going to copy their print line as well for the message for now. And then we need to self.connections.insert. And then we have the name.clone and the connection. I'm not sure. There's less indentation levels this way than the match would have. One less. I don't know. I like to have the option. By this, I did mean self.connections, which will probably fix a lot of the other things. MIDI in. I definitely meant self.MIDI in here. And probably here. And then here we get... We don't have partial equality for string versus string, which is fine, because I think we do this, and that should work. And then, yeah, because that was string reference versus string. Attempted access key field, yeah, it's not key, it's .0. And finally, self.midi in connect. Can't move out of borrowed context. I hadn't realized this would have moved anything. I certainly don't want it to move anything. That one's a bit odd. No. Iflet is rusty. Swift stole it. I actually don't know. Okay, yeah, connect actually takes self, not a mutable reference to self. Okay, that is actually going to be a bit annoying because that means we have to create new... Oh no, that's actually fine because we can actually just create new MIDI inputs like this. Okay, I actually think this is going to be fine. So then instead of doing MIDI in on here, I understood that to be like our context, but it doesn't look like it's going to be. So rather, we just want to recreate it here and then not use self.midi in. So we can do this. I want to do it here because it shouldn't, I wouldn't imagine it would be heavy to recreate these. Maybe it is, but I doubt it. And then here, we'll not use self.midi in. Yeah, we should be okay. And then, yeah, get CC value, still not doing anything, but we should at least get the messages out here now. Oh yeah, cloning probably would have worked as well if clone is implemented there. Doesn't look like it is, looking at the code. But I think this is fine because it looks like this was sort of the intended use anyway, rather than what I was thinking. So, okay, it worked. So we're getting messages in. Radness. This is from my MIDI controller. I mean, it's the same output that the test project had, but this is still pretty rad to see. So I'm happy about that. So I want to get this so that at least the MIDI CC signals are gonna go to something on the effect. I want to get to that today, and then I'll call it quits for the stream. Because that'll actually be a huge weight off my chest to get that done today. So I want to do it now. And yeah, so we'll do that. But yeah, that's pretty rad. And if I start messing with this, yeah, see now I get these unable to find MIDI ports because it's not all the way on there. Which is exactly what we should have. And then when I fix it, then it should have connected. And that appears to work just fine. Now, I think there are going to be some corner cases like if we disconnect the MIDI device and all that crap, but whatever. Hey, the Swiss. Yeah, there's a C++ GUI layer here, but yeah, at least all the MIDI stuff is on Rust. Although it does wrap it wraps the native APIs, but that's what you're supposed to do. But yeah, we've only touched Rust today, which is nice. So now we need to get it so that we keep track of these values. So what I'm thinking is that per connection, we want to have, so right now we just have the MIDI input connection, but I think I want to have a table that per connection, we have a map from the controller number to a value, which we should be able to build trivially with this. So these messages here, if we don't care about the timestamp, which I don't think I do, to be honest. I mean, I guess it's possible that we would have ordering issues. Maybe I want to keep that around. Looking at the timestamps here, they don't appear to come out of order. I'm going to ignore the timestamps for now and just have a to-do. because I've been bitten by that before with MIDI, but I'm gonna say it's probably okay because that was MIDI out of Ableton Live. With these kind of controllers, I'm guessing it might actually be a little nicer, but we'll see. So this will give us the message, and the message I'm guessing is going to be sendable. Oh, it's actually just a slice. Looking at the function signature, and that's fine. Because I can just copy that or clone that, I guess. Collect it into a vec and send that over. That should work. Yeah, that should work. So okay, so what I want to do then is extend these connections here. So here we're gonna have the inner connection. Which we probably will never actually reference. So we're going to want to do this. And this is nice because we'll still get the lifetime here. And then we need our values. So it should just actually be something like this. Value is going to be a hash map from U8 to U8. Because MIDI. And that should basically be it. Then we'll have, yeah, this is all becoming more and more clear. The other thing that we're going to want here is going to be that join handle, I think. This channel. Just looking up the API usage there as well. PSD channel here. And we're going to, whenever we get messages here, I'm still going to print these out here because that's fine. Actually, let's in fact, or well, actually, we'll drop these for now. Yeah. Let's do this. So we need, first of all, connections here. Yeah, we'll do this. Yeah, we'll do that to actually create the connection object. And then here we're also going to create the channel. So do let. Or we'll do the TXRX. Those names seem to have disappeared from the docs, but I still like to use those. And we'll do channel here. And so then here we're going to have the transmitter, and we can send this, and we'll do, yeah, we'll get that in a vec here. In fact, I think we can do and then we do message dot extend or something. Extend from slice even. That's what we want. And then we can just send the message bytes here. Perfect. And then the RX, our receiver here, is going to be part of our thing. What is the receiver type? It's just receiver of T. Yeah, nice. This message receiver. So here we want receiver and channel. A little off topic, what's the area I think Rust needs to improve on most? Oh, that's a really good question. Compile times, actually. Straight up. I think that's actually it. Now that I think about it for like 2 seconds. I think it's going to be compile times. It'll be vex v8s. That'll be nice. Yeah, so here we have our message receiver. Oh, this is nice. It's going to be rx, and then we have our values, which is going to be hash map new. See how nicely this is gonna come together? I think it's nice. Yeah, that's sweet. I totally agree. It's just I just like Rust is just so nice to use for me that I kind of forget that it has a lot of issues. I mean, any tool is going to, but definitely compile time. Dark Second, did you read into the new lifetime stuff? I haven't read into any new lifetime stuff since a couple blog posts like a year and a half ago about non-lexical lifetimes. I assume that that's the stuff. Yeah, they're non-lexical lifetimes. I assume that's what's coming soon. I'm happy about that. That's another area where Rust could definitely improve. So I'm happy that that's going to come. So now on update, what I'm actually going to do is this. We'll do impl connection, and we'll actually do function update here. And we'll give this same sort of API. And so then here, we can just do this. Iterate over these. Just call update on those. And then here, we can actually grab all the messages on the from the receiver and just stuff them on. Update all the values with that. And if we get a lot of like values that don't exist, that's going to be fine because we can do we can use the entry API or something else to just return 0 if we haven't gotten any messages for that. So that could be cool. Yeah, the language server stuff would be really nice. It'd be so nice to just be able to like hover over this stuff and navigate to that in Sublime and just have all that be nice and work. Different editors and stuff. I mean, maybe Rust Enhanced is actually doing a lot of that, and I just haven't noticed. But yeah, it would be a little nice. It would be nicer to have all that stuff. So in update, we just need to get all the messages off of here. Now the nice thing is, I think we just use try receive with no timeout. I think that's all we need to do here. Oh, actually, we have try iter now. When did that come in? Because that's 1.15. Yeah, I can't use that. At least I'm fairly certain I can't use that. Yeah, I'm on 1.14 at the moment, so I actually can't use that, which is fine. So then we have try receive for that. I've done this before. In fact, I think I did this in a couple other places, particularly the Dynamic Asset Manager does this. Yeah, in fact, it's right here, which is nice. I'm just going to copy this loop structure here. And yeah, we'll get the event here. In fact, this is going to be T already, isn't it? So we'll do message bytes. Yeah, nice. Just to start off here because I don't know how to interpret these bytes yet. We'll do something like that. Oh no. Oh, I have sync here. I think I just need to move this actually. I found for string connection, yeah, because we just need the value here. And then so I'm still not actually putting anything in here, but this should help. And we're getting really close for this to working, or for this to start working. There's still the key input that I want to do for the pads, but this is gonna be fine for first run for sure. Although I'll definitely want both for this stuff. So we should now be seeing 2 messages for all these, right? Because we'll get the one on when we got the message and then we sent it over the channel, and then we'll get the woo from when it actually gets on the other end of the channel. And I don't expect, sometimes these will be like in groups of 3 or whatever because it's synced to a frame, so we may get multiple, but the order should still be preserved. And of course there's a timestamp, so if we wanted to, we could also like have a little buffer of these that we keep just for synchronization, but I think this is going to be fine. Or at least keep the latest timestamp and just always take that. But I'm not too worried about this. I think this will be fine. Just do these in order for now. This to do will tell me to fix that later if I feel like it. If it becomes a problem, basically. But anyway, this is printing out these bytes. Now, I'm not entirely sure. I need to look up MIDI CC message. And like the MIDI Association has great pages on these, if I recall correctly. So this is nice. So here we get the actual data bytes, which is fab. Particularly, we should be seeing, so like we're getting 176 on all these. So I just want to look at what 176 is going to be. So it's 1011. And interestingly enough, that wasn't any of these, but I think though, here we go, status bytes 176 through 191. I don't remember how to read these actually. What to do with these first bytes. Summary MIDI messages, let's try this first. Right, so we get like the channel voice messages here. Yeah, so 1011 is exactly a control change. And then we have additional bytes here. So what is the N here? Oh, that's the channels. We don't really care about the channels. So we can just look at these bytes right now, or these bits right now, particularly for B0. I think I would like to do that here. So I'd like to just like send the bytes from here and just interpret them here. In fact, we'll do this as well. Move this here now. Same thing here. Except now it's messed bytes, which is fine. So now we're going to do just going to directly index these, and it's going to be fine. And 0xF0 is 0xB0. I think 176 is B0, yep. Then we have a control change, which is what we care about. And then we have the control number and the value after that. Perfect. So then all we actually have to do is self dot values dot insert message bytes 1 and message bytes 2. And these are the wrong delimiters. Yeah, there may be some additional things for these, but I think this is fine because I know that these kind of numbers are configurable. So I'm really not too worried about getting these numbers right, as long as I can configure the MIDI to do whatever. And this is trivial to change with the way I designed this feature in the tool, so that should be fine. But I think so. That's it for actually getting the data into this values map. And then here we want to pull it out, right? So here we're going to do let name is self dot port names, port index as usize. And then here we can do something like this. So here we want to do the entry API to actually pull the value off. Oh, we're so close, you guys. I'm actually really happy about this. It's like 2.5 hours, including being distracted and on stream, and then this just works. That's awesome. That's really, really good, I think, to be honest. If I do say so myself. So we get the name, and then we can do self.connections. So we know the name is valid. So we can do self.connections name. I think we can look at that. Or actually, I think it's get name. Yeah, I like that better. And here we can even actually... no, we'll just do it. We'll just look up the value here. We don't really need to defer this to the other struct because it's all just right here. And then here we'll do controller number, except here, yeah, again, we want entry. And we don't want to do or insert. Actually, this is what we want. We just want to do get. We'll do unwrap here. And I think this is unwrap or 0. And I think that might just be it, which would be awesome. So close. We need to do this. And this wants references to this crap. That's not what we want. We can do this. Dereference that. Actually, isn't there like a deref thing on an iterator or whatever? Something like that, isn't there? Something? Could have sworn there is for this. There's, oh, what is it? I mean, this is fine. I just like, I'm pretty sure there's a way to do this. Nah, screw it. Do this, which is just fine. And then, what's our error? Expected F32, which is actually awesome. So we'll do... So here's the byte value, and then we can do byte value as F64, actually F32 divided by 255.0. Oh, and then we need to, when we send the message, I'm going to unwrap that. Bam. Moment of truth. So now when I tweak this knob, I think it's working because I can see the time kind of shift, but I have to go like really fast for this. So I think this is totally working. It just is like not at all visible here. So I'm going to move this somewhere else. Yeah, I also think I have the range wrong. I think you're right about that. Where do I want to put this? We'll put on the aberration amount. Yeah, that's where we need this. I feel like this isn't working though. I mean, I could also multiply this by like 10. Let me save this and fix that range. I'll get this working. The other thing is that this MIDI controller right now, it seems to be configured to send out absolute values, whereas my other one seems to be configured to send out like relative values when I turn the knob. So I gotta configure that. But I think that's up to how the controllers themselves are configured, not the tool. Oh yeah, there we go. So now I have aberration on this one knob. Awesome. That's so cool. Let's turn that up here. About like 100, because that's awesome. Bam! Oh, this is great, you guys. Look at that. Hells yeah. Check this out. This will make a great VJ setup. Look at that. Already that looks like VJ fodder. Oh, how cool is that? So I'm going to clean up the output here a little bit. Although admittedly, I kind of like that it prints this right now. Because like when I do a lot of controller stuff, it's actually probably going to be really useful to have this. And given that it's probably not really slowing anything down, this is probably actually fine. So I'm actually probably going to leave that. So let's see where I'm at git-wise. Not that much stuff for touching the entire stack. Yeah, this looks great. There should only really be that one to-do, which was to see if we want to use timestamps, and I'm going to wait on that. Wouldn't make it like ridiculously more complicated, but it would make it more complicated. Maybe I didn't want this comment change. I think I actually will remove that change just to keep all this in one commit. So that was... What was it? Git reset head and then that. Then we can do progressive add on this and just skip that one. Everything else looks good, I think. Yeah, we'll reset that. Cool. Take that off my list. Oh, that actually feels really good to get to do that. And then the last thing I'm going to do is just reset this. Because we didn't need that comment change. I'm really kind of a stickler about that even in my personal code because never know when we need this commit from this branch and this commit from this branch. It's not that hard to keep that stuff nice, to be honest. Yeah, I could do that print in debug mode, although we always have to build and release in this case just because there's a bunch of performance critical stuff here. Yeah, I don't really have that kind of differentiation in the tool, but it's fine to just always print it, I think, because I'm not printing out much else other than like shader compile errors. So I think it's fine, realistically. Oh, the other thing I want to do, well, okay, I'm actually going to get relative stuff from there, but maybe it's worth a shot, is trying the other MIDI controller as well. See there, Drew, too. Oh, I need to make some more post effects. Just play with them like this because this is going to be cool. Mirroring and stuff, having all this hooked up to this stuff, it's going to be really nice. So yes, this totally works. Super happy with that. Let's do this so that I get something else from my other controller. For example, what do I want to do here? We could do the amount of logo. Now we get the Logic Coma logo as well with that. It's kind of funny. That's so cool. For example, if I do 2 here, then I should be able to have 1 knob for the Logic Coma logo. In fact, there I don't want to multiply by 100. There I actually want to do like by 10. Oh, that rules. And then the other one for the aberration. So I have independent control of those, which is really rad. This is going to be a cool tweak tool as well. And then I want to see if I can use the other device for this as well, which got to scroll up a bit because of this output. But you just need to know the name of the device. It's going to be the Ep.023. So here we'll try something like this. Oh, what? What did I just do? Ooh, we got a none value on a panic thing here. Unable to find MIDI port something. The name was blank. Does that become an error? Might have to fix this really quick. It should have been fine, because I don't know where we unwrap something here. Interesting. I guess here, but that wouldn't have happened unless we got a port index. That's a bit odd. Oh, I don't want to use Ableton for sync again. Generally. That was overall a pretty painful experience, to be honest. Not necessarily Live's fault either. It's just the way everything fit together. Did not work very well for me. Where's my aberration amount? Here. So why did this break? Is it because... Okay, as soon as I don't have the proper port, then I get the unwrap somewhere here. It's not going to be here because the port list is going to be fine there. This is just going to list those with I here. So where is this going to happen? Probably here. But how could it have gotten here without a port index? The file name and line that it's giving me right now is from libcore option because that's actually where the panic comes from when you do unwrap like this. We can do expect like this though. And then at least that will narrow that down. Oh yeah, the backtrace. That's actually a much better option. Just run it with that because I'd rather honestly not have a bunch of these expects. Because as soon as I have one expect, I have the... I always want to do all of them. But yeah, we'll do Rust backtrace. We'll do this. Oh, that was helpful. Well. Ugh. No worries. We can just expect our way there. Weird though, because that totally was fine earlier when it couldn't find one. So I don't really know what the issue there might be, but we'll see. Because we need to have the ability to support bad names here in case I load the project up and we didn't have the same thing and I need to change it, basically. That's where it's going to be the most interesting. I'm honestly going to do this. Because I'm too tired to look into settings and stuff right now. I'm just gonna do this. Printf debugging like a champ. And then I gotta go. Otherwise, I'm gonna be up till like 2 in the morning just because I stayed up too late coding. Yeah, I mean, our code is assuming that the wrapper library, the MIDI library we're using, is at all sane. The code we're doing isn't really that complicated. So I would expect this to be pretty reproducible here. All right, so here. It got to A and then didn't get to B. What? Yeah, it's not too late, but the problem is that I need some ramp down time. Otherwise, I'm going to end up staying up late, if that makes sense. Like, I'll still be awake late, even if I didn't mean to. So that's why I bring that up. And I've really been trying to be more careful about that. I don't like the idea of this being what it was, but let's see. But I'm really happy that that this is working already, because this is gonna make this whole thing really fun, I think. I need to then port a bunch of like scenes and stuff that we do to like not use cameras from Rocket, some things like that, and get them all into one project. And I also want to add some more just like crazy post effects and do some layering stuff. So I think it'll be really cool when all this comes together. And I mean, we have 2 weeks, which realistically is actually a lot of time for this kind of stuff. Where is this unwrapping? Between here and here. I mean, it's possible that in the release configuration we're getting like some stuff out of order here, but still. I don't honestly know if I can do debug for this, as I don't remember how all the pieces fit together and how they're linked. I probably can, but I'm starting to hit that point where I'm just so tired. like being tired just like hit me like a ton of bricks. Probably like right when I got this to work. It was like, yes, I can relax now. Oh, that's a good point, actually, that it is printing that, isn't it? That's actually interesting. In fact, now that you mention that, I think that's a really good clue. Yeah, it's not in this code, because A is out here. So what happens is we get A here, prints this. Oh, it's here. It's totally here. That the connection might not exist here. This is where it's failing, I'm sure. Get rid of this one here. This guy. So we can do this. Oops. Actually, here we'll do... here. Yeah, totally. This is why you don't unwrap, but it's fine. Actually, I do want to match here because we do have the 0 case. Or, actually, I'm going to get cheeky here. So instead of unwrapping, oops, Butterfingers over here. Instead of unwrapping, we're going to map. Something like that. That's kind of ugly, I think. But it should work. But that makes sense, because then we didn't have a connection in our connections list for that given port name. And actually, no, this should be fine. Because for every port name in, yeah, this makes sense. We may not have a connection for a given port name, but we always have the same port names that are available in the operator graph. So now if I go in here, that also explains why this didn't fail before. Okay, good. That works. So copy this. And then from my other controller, 91 is apparently the number there. So we should just be able to do 91. Yeah, buddy. Oh, this actually is giving the full value too. Oh, sick. All right, so now we have... Oh, this is really cool, you guys. So let's map this to something else. Like, again, we had the Logicoma logo. So we'll do the one on my right for the... No, we'll do the one on my left for the Logicoma logo. And the controller on my right for the aberration. And then I'm going to totally... double fist this motherfucker. There goes my filter. It's that time of night. Oh yeah, I should move the window for you guys. Sorry. All right. This is, oh yes. Check that out. I've got aberration on my right and the logo on the left. Oh, this is sick. All right, I'm pretty pumped now. Yes, Power Glove is exactly what this setup needs. You are absolutely right, Skeleton. Oh, this is ridiculous. Also, this is a bit too much for the left one. This is what's really cool about having this sort of setup is I can just adjust how much this is. So sick about just doing the... That's why I want to do the MIDI CC. It's just like another expression type because then it just fits with the rest of the pipeline so well, which I'm really thrilled about generally. Yeah, so now we actually have a bit more control of it. That's still a bit much, I think. So we can do like 2. I want to get some more range of motion here. Yeah, I can't do that today. Oh, that's why. I'm editing the wrong one. Durr. That's how I wasn't seeing any like obvious change there. So we wanted the masking pass logo mask here. That's what I wanted. So we would get some more range of motion. There we go. And kind of fade a little bit with the logo. Oh, Evoke's going to be cool. I also have the mouse movement here, so I need to hook that up to different knobs as well. Sick. No, so I only did the MIDI CCs for now. I don't have the key mapping yet, but I'll do that later. Oh, yeah, right, Tony, you said that. Thanks. But yeah, this was super successful. This totally works now. This is half of the MIDI support I wanted. The other half is at least getting some kind of like pulse from the keys. Because with the keys, you usually want some kind of like envelope. I think the simplest thing for me to do, honestly, is just have a pulse whether or not a key was hit in the last frame. I mean, at least for just experimenting with this particular show that we're doing, I think that's going to be enough. So I'll probably do that because I can use that to set variables. Particularly, I want to use that again to use like drum pads to select scenes. But I'll probably do that on my own, or if at the latest next Sunday. Next Sunday, since I'll still be preparing for this, I will either be working more on this tool, but it'll probably be done by then. So then I'll probably be sitting there tweaking effects and just throwing stuff into one big project. That'll probably be my next weekend. But yeah, so this was really cool. Thanks guys for hanging out. And yeah, I'll see you next time.